Well, okay, welcome everybody. I'm going to try and provoke you into feeling guilty about the way you practice your software architecture. Okay? By the way, I can't resist asking, how many people have a degree in architecture? No, I didn't think so. Now, how many have some kind of a degree in engineering of any kind? Software engineering doesn't count. It's not real engineering. Okay, so, interesting. About a third of the audience is somehow into engineering. I'm going to try and sell you on the idea that you ought to do your architecture as an engineering discipline, not as a programming or artistic or poetic discipline. Hope I succeed in selling a few people on that idea. We'll move towards real architecture engineering. I start by wandering the world as a freelance consultant in all kinds of businesses, but quite a few of them, in fact, here in London and quite a few in the city. And I look at quite a lot of work of IT architects, or whatever type of architect they declare themselves to be, and all I find is poetry. Nice sounding words, almost mouthing management bullshit, okay? And they're nice sounding words for the inputs. They're going to build a highly adaptable system that will be very secure, and they're going to do it through modularization and some kind of a GUI interface. And that's all they say, nice sounding words all over the place. And I don't think that's good enough for the scale and class of systems and the dependency of society on our systems. We have a huge failure rate. And IT architecture hasn't changed that failure rate. Lean and agile hasn't changed it yet for us. In fact, nothing's changed it. We've got to have some fundamental shift in our bad habits, our evil habits of trying to build very complex systems with far too simple-minded methods. Let's call it architectural poetry. And I'm going to argue for architectural engineering. Okay. Now, I promised in my talk to I like to have 10 principles of everything, just a way of summarizing things. And so, especially for this conference, never before, actually we did a trial run of this. 4 of us who were talking here also reside in Norway, so 3 of us got together recently, and I did expose these principles in Norway. So I wrote down my 10 positive constructive principles of how we ought to do things. And here they are. Now, I'm going to actually go through these in detail towards the end. And you'll see a lot of case studies and examples which will enable you to absorb the principles somewhat better. But if you like, take a quick look. We can start with just the first one symbolically. Architecture is a hypothesis, that is the architecture specification, that needs to be proven by implementation and measurement. In the moment I say that word measurement means how good is the architecture, we've moved to engineering. Okay, so that's just a little sample of the thinking. But I intend to go through these at the end, time permitting, and it should, even a generous quota here for Keynote, so we'll do that. Here's a simpler version of it, and I did it this year at the ACCU in Bristol. But we summarize some of the ideas. So architecture is the servant of the prioritized or priority stakeholder values. We start with the idea of values of people, right? And we are the servant of those values. Our job is to find technical stuff that delivers those values. The focus must be on the values. I haven't heard that word mentioned too often at this conference yet. Okay? Now, values are a class of requirement, but for example, having functional requirements and use cases are not necessarily the same as values. Okay? But I will speak a lot more about what I mean by value ideas. The architect is responsible for knowing and specifying all values and costs. So if there are 10 or 15 critical values, you have to know what they are. What does know mean? Know means, in my book, know them numerically. Not just very user-friendly, but exactly how user-friendly with a number. That's what know means to me. Okay. How many people say, well, you're preaching to the converted. We always quantify all the top-level values that we're doing our architecture for. We got to meet, we got to talk, okay? Was there more than one hand going up saying we quantify the high-level values that are inputs to architectures? Oh, you're all virgins. You're all going to maybe become engineers. okay? But this is too simple for the complexity of what we do. Anyway, and the values and costs, long and short term. In other words, immediately, but maybe in 10 or 20 years' time, there will be costs and there will be values, and we have to consider them. So the short term and the long term has to be carefully considered. This requires numbers for the timing, as well as numbers for the values, okay? All architecture is suspected of having disappointments and surprises until proven otherwise, and it says but, and it should say by, real system measurement, okay? In other words, your architecture is not proven until it is measured as having delivered the capabilities, meaning the values of the stakeholders within the costs in the short and in the long term. So how many people put their architecture to that test? We measure the results of our architecture compared to expectations. Were you just scratching your nose, or was that a hand going up the back? So, okay. This is not the convention, so I'm definitely speaking to the unwashed masses, virgins, and hoping against hope that some of you, even if only one or two of you, will actually take this seriously and become serious at being an architect. Okay? All architecture should be removable when implemented if it fails, or if we get a much better idea. We shouldn't be finally committed by the fact that we wrote a 6-year contract with a supplier of a component and we're stuck, or anything like that. Everything should be reversible. Okay, so I've already asked this question, are you an how many people say, I'm already some kind of a software architect? That should be a lot of hands going up, right? Okay, and then, but the question is, what is an architect and what is architecture? I hope it's emerging that I have a slightly different definition from what you might have had. Okay? Yeah. Now, my favorite building, well, I reside in Norway, and this is Oslo, and this is the Oslo Opera House, which won a prize for, from 800 candidates in Europe for the best architecture. So it's a pretty good piece of architecture. It's an amazing building. On the first day of opening, or first weekend, 25,000 people walked on the roof. You see the roof? That roof is symbolically a white Norwegian mountain. So Norwegians love to climb their mountains. And so somebody said, well, if we can build an opera house, we've got to build it so Norwegians can climb it. Okay, it doesn't matter whether you actually go and listen to the opera. That's irrelevant. But walking on the roof of the opera, imagine the Royal Opera House or the Colosseum. Imagine walking on the, there's no such thing, right? But in Norway, we don't walk on the roof, but we have concerts on the roof, okay? And imagine the fun the skateboarders have, too. Yeah, yeah. Brilliant. So, lovely place. And in fact, they put on pretty good operas and ballets there, okay? Now, what did it take to build the opera house? Well, first, let's look at the word architect. And I used to think it meant something about arches. Thought that was obvious. But finally, when we looked it up, it meant master builder. Okay, fine. Now, basic idea of my whole talk, the architecture is there to satisfy the requirements. And the requirements are the values of the stakeholders. And they are quantified, and they are measurable, and they are testable. And they're testable immediately and incrementally, not just at the very end of a very long project. This is called agile. And agile, with its iterativeness, offers a special opportunity to architecture, to test the architecture early, frequently, and measurably, and dump it when it isn't working. Okay? So now this is just from my imagination, but obviously there were some qualities expected in the opera house. There were some costs, although the Norwegian government flow with oil wasn't too worried as long as it impressed Angela Merkel, who was one of the first people they ushered in, say, look at our great opera house better than your German opera houses. Okay? And there were some constraints, like if you hit a Viking grave, and all building will stop until we've excavated and checked out our history. Okay? So now this is typical of any project. There are some qualities or stakeholder values that are expected. There are some resource limitations, people, time, money, space, that kind of thing. And there are some constraints, such as laws, that regulate what we do. And we have to, architecture has to live within this framework. What I find is qualities at best are listed by name, you know, very user-friendly, highly secure type of thing. And that's it. It stops there. and that's not good enough because it's not clear what they are. Costs, I rarely seem to find architects dealing with costs for some strange reason. They spout all these cost-containing architectures because the cost is in the architectural idea itself. But I can't recall ever having seen somebody toting up the cost for each individual design component in the total. How many people say, we cost our architecture in a thorough and responsible way? Ah, my God, 2 hands went up instead, or 3 instead of 1. So in other words, how many people would admit that, no, we don't really have a costing of architecture discipline? Can I see a lot of the other, just checking. You know, sometimes I say, how many people can raise their hands and just to check, right? Okay, so we admit we're not very good at cost. Now, again, architecture is a tremendous cost driver. It can make the several orders of magnitude difference in what things cost. So obviously, we ought to be costing our architecture and take responsibility. And obviously, I've just demonstrated that we don't seem to have that as part of a discipline. That's just the beginning. Do you think real architects don't bother with costs? They don't have any cost constraints? They don't consider it? Of course they do. Yeah. Now, just for fun, I put in some words there, some symbolic qualities that obviously they've got to think of the acoustics and the access to the fjord view and the comfort of the people and whether it's impressive for visiting dignitaries and stuff like that. They'll probably be handing out the Nobel Peace Prize there shortly, but they're using a building from before the war, really. Now the Oslo City Hall, which is pretty interesting. Okay, and then all kinds of constraints. So this is symbolic for a set of things that an architect must necessarily consider, because they're not going to achieve all this by accident. They're going to achieve it because they were conscious of exactly how impressive it had to be, and exactly how good the acoustics had to be, and exactly how flexible it had to be for changing scenery between opera and ballet. The whole Royal Opera House had to be radically rebuilt in order to avoid driving away the opera scenes overnight to bring in the ballet scenes. They've done that, but it wasn't engineered that way to begin with, so it was terribly expensive and time-consuming. Okay, so, but symbolically, any project we have has a set of qualities, I'm calling them. I'm defining quality as anything that defines how well the function is done, how well the opera house is doing things, okay, the degree of goodness. Very broad. So many people in our business, when they say quality, they really just mean bug-freeness, and that's it. That's far too limited a definition. In the rest of the real world, including your real world, when the quality of a car, quality of an iPhone, quality of a conference speech is multi-dimensional and not limited to bug-freeness. See, the bug-freeness of my talk isn't that interesting. Okay, you found a bug there, the word but instead of the word by, but what the hell, you know, doesn't count much. Okay. So, now again, reiterating the main theme, the architecture is there to satisfy the requirements. Okay? So you are judged on the degree to which your architecture suggestions satisfy a given set of requirements. Okay? Now, if you have an architectural culture that never refers to these qualities and performance characteristics, costs, and constraints, I would say that couldn't really be architecture. That's architecture under false flag. That's something called architecture which isn't and cannot be, because it's not dealing with these requirements. And I find time and time again that the architects either have ignored the critical requirements, or they've been satisfied with oversimplified management bullshit requirements of the type very flexible and highly competitive, which mean nothing or no use. But they said, well, they take a look at them and say, okay, I'll build some good architecture. And they certainly, as we've already demonstrated, don't have a habit of pinning down those ideas quantitatively, measurably, and trackably so they're totally intelligible to the architect, which I'm going to argue we should do. Okay. So architecture is driven by requirements. It's staring at really clear requirements that should lead to you saying, I need this architecture, I need that, and this is justified and this isn't. And architecture which is not clearly driven by clear requirements is, in my view, no architecture whatsoever. So I'm going to make a distinction between real architecture and pseudo-architecture. Pseudo-architecture is what you lot are practicing for the most part, except for the man sitting there right now, okay? Unless he's lying to me or something like that, but we'll soon find out. So, just trying to be impressive, the only guy in the room raising his hand. You didn't realize that nobody behind you was raising their hand. Okay. Anyway, just out of curiosity, your practices, where did you figure out that you should do these laudable practices? Any source of ideas or common sense? Okay, chemical engineer. Yeah. Okay, so you're just doing the kind of stuff you were taught in the architectural environment. And it really is my recommendation that we do transfer our engineering knowledge to what we're calling software architecture, right? That's the patterns and things like that. So real architecture, first, it's clear, it's dealing with multi-dimensional objectives. Let's call them the qualities. They are clear, meaning they can be tested and measured. They're not wishy-washy, very competitive, highly adaptable management bullshit. We can't have management bullshit in serious architecture. We will get managers bullshitting us, but we can translate their bullshit into something clearer, is what I'm saying. Okay, we can feed it back to them and say, is this what you meant, sir, when you said very adaptable? And if they say yes or no, we have an insight. We can deal with it. Okay? Right. We need to have the constraints. For example, a very clear idea is it has to be delivered then. It cannot, the budget is that. The number of people you can use are so and so many. The amount of space, say in storage of a mobile telephone or something like that, is limited. Okay? And the architecture process needs to produce architecture ideas which enable and permit those objectives to be met. Okay? Enable and permit is hinting that there may be a second level of engineering, such as performance engineering, man-machine interface engineering, security engineering, which is far more specialized, but which is operating under constraints and frameworks set by the architect. But the architect may not finally determine the final design. This is normal in many engineering disciplines, such as aircraft engineering. Okay? And then we estimate, which most of you said you didn't do, the expected effects on the qualities and the costs as a way of saying, I think this architecture is good enough, let's try it out, let's measure what it really does, what it really costs, before we finally commit to it. Pseudo-architecture doesn't even pretend to do anything and doesn't even feel guilty about not quantifying things, not costing things, and stuff like that. So that's you lot. You're in the pseudo-architecture group, as far as I could determine from your hand waving. So here's a pseudo-architecture. Now, there's a website at the Software Engineering Institute where anybody can write their favorite definition of architecture. So you can go there and write down your definition of architecture. When I was last there, 200 different people had written 200 different definitions of architecture. I put one in too. But I noticed there were two kinds of definitions. There are what I call the boxes and balls crew. It says architecture are the components and interfaces, blah, blah. There are even some standards like that. But they never mentioned the idea of requirements at all. And then there's the other lot who's got it, as far as I'm concerned. And they did actually, so here's an example of the first lot, right? And here's their boxes and balls, things where these little lines indicate influence or effect, but there's never any quantification of whether it's a 0.1% effect or a 99.9% effect. And frankly, there's a difference, and I'd like to know about it. And not knowing about it means you cannot do your architecture very well. Knowing there is some relationship, but not knowing how much, that's silly. Okay, that's neither science, engineering, nor good management. Okay, and unfortunately, we're stuck in this. There's a relationship, and I'll draw a line, and that's about all I'm going to do for you. And I think that's just not enough. Now, better definitions that I found specifically mention one way or the other stakeholders, constraints, goals, requirements, and said, aha, they've got the idea that I'm trying to put across here, that our architecture is very, very related to them. And any definition of architecture, any practice of architecture, which does not deal with the requirements is not true architecture at all. It's somebody culturally spouting some nice-sounding ideas, hoping he'll get paid for it and get away with it. Okay. Symbolically, here we have some tables. These are actually from a case study that my son did at a Norwegian post office organization, where we're modeling the business, the stakeholders and the technical design level, and we're doing it with numbers. These are simplified diagrams. And these three levels are related to one another with numbers, i.e. the IT is related to the top management business objectives directly. And we can see the knock-on effects or connections. Okay, so this is engineering. This is modeling with numbers. This is getting a clear idea of how the IT hangs together with the stakeholders in the business. That's real architecture. We'll see more of this particular device. It's called an impact estimation table later in the talk. So let's just get some definitions on the table. The architecture process in terms of buildings, when somebody 20 years later wants to make a change to a building, they ask the original architect, if I do this, will I screw up anything else? If I make it more beautiful here, will I screw up the air conditioning or acoustics? Only the architect has that overview. So this idea of lifelong responsibility, so that anybody making changes is forced to look at the whole picture and say, are there adverse consequences that I wouldn't see from my domain of security? And will it destroy the necessary minimum user friendliness in the system if we do it? Okay. So how many people have a notion that the architect is responsible for change during the life of the system? Good. That's like at least half of everybody. Okay. And how many people actually get asked when they should be asked to look at changes? Not quite as many, right? I think 2/3 of the hands just went down there, but okay, that's bad practice of your organization. Anyway, architecture specification is some set of means, also called architectural components, for a set of ends, also known as stakeholder values or requirements. Okay. So that's just a model, a specification of what we think we want to do. So this process is generating that specification. That specification leads us to make decisions, what are we going to do when, let's try it out. If successful, we keep it. If failure, we find something better. That's the dynamic process. Okay. So I'm going to argue that there are some absolute essentials, you can't live without them, for a decent architectural process. You need clear multiple objectives. So I often talk about top 10 quantified on a single page. I'll be showing you examples of that. Clear constraints, exactly which laws do we have to follow, which budget constraints do we have to worry about. And we need a process of analyzing our architecture to make sure that it meets the constraints and goes towards the objectives. The architectural specification has to have well-defined components. I'm going to go into some depth about what I think is a well-defined component. But usually I find people just throwing out a word or two or three as simple as modularization. And they're all done, okay? I'd write a whole page about that modularization to talk about a specific modularization that would attack my goals within my constraints, because there are about, at least 50 billion classes of modularization. So it's almost like saying the architecture is good architecture. And I've actually seen that specification at a real Ericsson project once. The architecture best practices should be used. And I asked, what was that? And they said, no answer. Won't tell you. But it's like saying the answer to an exam question is the correct answer, whatever the hell that is. That's cheating. Okay, so people do that for real. Why are these essential? Because if you have 10 critical objectives, definition of critical is if one of them, like availability, totally fails and you have availability 0, then nothing else counts. It's not visible. Your user friendliness won't be visible if you have 0% availability, right? So critical means, it's like life-critical things here. If you freeze to death, nothing else going on in your body is very valid. You're dead. Okay? If you suffocate, doesn't matter how well you ate and what you drank, you're dead. Okay? These are medically critical factors. So in other words, any real system has a set of critical factors. And it's a first order of magnitude. We identify the critical factors, i.e. things which, if they go badly, kill the whole system. We're obviously very bad at that since our failure rate starts at 50% of all IT projects. Right? We're not very good at that. And identify and master and control them. And architecture is the first line of defense of controlling the critical factors. Okay? Engineering is the second line of defense. Programming, testing, and even design at the programming level is the third line of defense, etc. So you cannot expect your specified architecture will accidentally reach your objectives. They usually are ambitious. The budget is usually paltry, And you really have to use a lot of mental energy to find really clever stuff which is cheap enough to satisfy people. That's the job. So throwing in random ideas with badly defined things is a clear recipe for the disasters we normally experience. If you're in any doubt about that, you can Google software disasters or something like that, or software failures, and you'll find amazingly rich literature on the subject. Okay. So the real architect does all this good stuff, and the false architect, what me worry, I get paid, I get this wonderful job called architect, I spout all this bullshit, but the managers don't seem to notice, so why should I change? I just wonder how we're doing here. How many people say, even if my company doesn't really care, I would like to do things properly and first class? Ah, there is hope. Imagine if just one of you changed. I've had that happen before. I've talked to audiences, and 10 years ago, and one person in that audience goes and changes the whole of Intel, how they do things, that kind of thing. Okay? That's why I only want one of you who's going to change his world, maybe his whole corporation with these ideas. It's possible. Okay? But it'd be nice if it were more than one. Okay? Is anybody who volunteers to be that one? I mean, I'll support you. Hey, good. I will support you. I will help you in Poland. Right? Okay. Next week. Yeah. Okay. Just for the fun of it. Okay. Okay. So now, we're going to throw in the term engineering after the word architecture. Haven't heard that too much here. Okay. But that's my paradigm shift. We're going to move from architectural art and poetry, and we're going to move to an engineering discipline, because that is necessary for the scale, complexity, and criticality of the projects we're doing. You don't need an architect to build a dog's house, but we know we need an architect for a 200-story building. What we are building now are more akin to 200-story buildings. It's obvious we need really good architecture and really good engineering, really good craftsmen and construction to build the 200-story building without it being a failure of some kind. But we're not practicing that in architecture. We almost have architecture good enough for dolls' houses, okay? But absolutely not good enough for the 200-story building. Anyway, so the architecture engineering process is considering these quantified objectives and constraints and things like that, and hypothesizing, I think these architectures will do the job, and estimating how well it will do the job, and then proving and validating evolutionarily or cyclically or agile, step by step, proves the architecture or proves that it doesn't work. In other words, the architecture is initially a hypothesis, as in scientific hypothesis, and building and delivery steps try to validate or not validate the hypothesis about the architecture. But architecture must be proven by measuring how well it works in relation to needs and expectations. Now, here's a map from this book, and at the end of my talk, I'm going to offer you all a free digital copy. Okay? So all you have to do is email me and say book, and you'll all get a free digital copy. And this gives me a measure of actually how many people are actually theoretically interested in learning some more. I'm happy to get 200 emails in the afternoon. They'll be answered by this evening. Okay? But, and if you're not smart enough to figure out how you email to me, you're not smart enough to read the book anyway, so I don't have to tell you my email address. Actually, it's down at the bottom of every slide, so that shouldn't be too subtle. But if you can't figure that out, you're really doomed. Okay. Now, I've defined a lot of concepts fairly thoroughly, about 600 concepts, even fairly basic ones like what is a design, what is architecture, and what is a requirement. And this is my world. So it starts off with a world of engineering and a sub-world of systems engineering. And then part of that world has systems architecture, which just for fun I call systecture. And if you get into the software, it's called soft-texture, and you become a soft-tect. No? Never really caught on, but I thought it was a nice try. Okay. And so here we have architecture processes, which I'll be talking about, and some architecture specification types, which I'll be showing you during the talk. So this is my world of, in other words, I don't just think we ought to do it in principle and exhort you to do it. I've heard a few talks even here that are exhorting people to do this and that, but they don't actually show you how. I will show you in detail how. There's a difference. Okay. Here's another map of my world, the map of requirements. Okay, so I was having a chat with one of our lecturers from yesterday during the speaker's dinner, and he accidentally mumbled non-functional requirements twice in a row and said, I have to stop you here. I won't say his name. And I said that I regularly lecture that if anybody says non-functional requirements, it's a sign that they're terribly immature and don't understand what quality is. All they know is it's not a function. So we had a little discussion about that. Actually, this chap here who raised his hand, I'd like you all to close your eyes a moment, at least symbolically. Right? I'm going to describe this wonderful man who does everything right here. He is not a fish. Right, you may open your eyes. Wave your hand again, sir. Right? Wasn't that very illuminating? He is not a fish. So saying something is not a functional requirement is not very illuminating, especially when the quality requirements are there, and there are all these other kinds of requirements. For example, a legal requirement is not a function, and it is not a quality. It is a constraint. Okay, there are plenty, so in other words, a little bit more mature people would understand that you can't just say non-functional requirements and imply that you're talking about quality of which you have no real knowledge, so you say non-functional requirements. So ban that term from your vocabulary, it's embarrassing. If you're talking about qualities, say quality, say which qualities, quantify them. And if you're talking about legal constraints or something else like that, or design constraints, say so. These are all defined in the book, by the way, for like definitions. Okay? The three-digit number with an asterisk means this is a formally defined concept in my planning language or planguage glossary, which is in the book. Okay, but this is just to give you my fairly rich world of requirements, all of which can be hitting an architect. And the architect needs to be cognizant of these types of requirements and looking for the ones that are missing to complete the picture before they go on and do their architecture. Here are some of the specification types we're going to be looking at, and I'm going to be showing you this more than doing it, but just say there is a map, there's a definition of ways of specifying this and that for architecture. And I also have a pretty heavy set of standards. And I'm going to take a look at one, there are different kinds of standards here. For example, defining a term very clearly is itself a standard. We've agreed what does it mean requirement? What does architecture mean? Those are standards. I have 655 of those. But policies are things like you really shouldn't allow the architect to start work without a clear, validated, quantified set of requirements. That's a policy. Now, how many people have that policy again here? One or two hands going up in back of you, sir. You have company. Okay? Because the architect's just wasting his time. Okay? Anyway, so now we have another concept called processes. Okay? The book is filled with processes. There's a process of quantifying inequality in Chapter 5, which is freely downloadable from the website right now. And we have templates, which we're going to show you some templates being filled out. So I just organized the knowledge in a set of standards, which it's my menu of how I think things ought to be done, but anybody can pick and choose and any of these ideas, regard any detail as a potential tool to be integrated with any other framework or set of thought. Things like TOGAF could probably use a lot of these ideas to get better. I found all the known architectural frameworks abysmally bad at doing qualities quantitatively. Take a look. It's not there. Okay, but they're frameworks. That means they do invite people to fill them out with better practices. So let me just say, whatever your framework, but how many people have had some kind of TOGAF training or education? I'm expecting to see some hands going up. Fewer than I thought, okay. But again, the problem with frameworks is, in a sense, they contain nothing and they're supposed to be filled. Okay, I'll give you a list of stuff you ought to do. And I've got a list of concrete stuff you can have for free, which can fill any framework you like. Okay, that's what we're doing. So I'm going to take a look at some details. So this is from Chapter 7 of the book, which is on design ideas. And Chapter 7.4 has rules. And I'm quite fanatic on having minimal set of rules. So everything is limited to one page. Okay, all standards are limited to one page. Okay, I found if you can't put the essentials on a page, you don't actually know what you're talking about. Anybody who needs a 50-page standard doesn't truly understand the essence of what people have to do. So here's a one-page standard. Now, rules are defined as rules for specification. rules for writing. A little bit alliteration there, rules for writing. So this is my advice on how you ought to write a design or an architecture. It's right here. Right. By the way, these rules are used in another context. When we do quality control of things like requirements and designs and architecture, we quality control against these rules. And every rule violation is called a defect. And we measure the quantity of defects. So we can measure the degree of violation from the standard or rules. This is in a discipline known as specification quality control, which is a separate chapter in the book. Okay? But for example, if an architecture specification had 100 defects per page defined at, say, 300 words, then they've violated one or more of these rules about 100 times. In other words, they've more or less made the architecture unintelligible and useless. Okay? We found that most people's architecture contains approximately 100 to 200 unintelligible words or statements per page. It's a normal measure, measured all the time. Nobody waltzes in with 0 or 1 major defects per page, even compared to a simple standard of clear and unambiguous. Okay? Try it yourself. Just go count ambiguous and unclear words in your own specifications per page. And if you don't find about 17 per page, you're not trying. And when you realize that you're only finding a sixth of what is there as an individual in a few minutes, and you multiply 17 times 6, you realize you've got about 100 unintelligible things per page. Try it on your own specifications. Okay? If you need some help on that, I'll be here the whole rest of the day. I'll help you do it. But your specification will count violation of even simple criteria like intelligible design, clear and unambiguous. Anyway, I'm going to go through these one by one, which I've never done with examples. So the first one basically says that we need to clearly separate the requirements and the design. Now, you'd think that's obvious, right? How many people have such a practice? We clearly separate requirements over here and design over here. Okay, I'm counting about 25%, okay, of shy. Nobody like, yeah, we do that, okay. Every time I see top-level objectives, I find that approximately 50% of everything is architecture in the top-level requirements. It goes like this. We're going to achieve high flexibility by using method X. See? Now, by is what I call a link word. And the moment I just go and count link words in order to, by, so that. You know what? The presence of a link word always signals the presence of architecture in the requirements. And in fact, you've got three bad things at once. First, you've got a vague requirement. We're going to get extremely flexible organization, okay, undefined. By signaling the presence in the requirements of somebody's architecture, usually from a top manager before the architect's even asked. You know, using business process re-engineering. Sounds great. It's about 1 million different things, okay? Now, that business process re-engineering should be elsewhere. And the top manager should not be allowed to dictate that architecture. Okay? What you need to do is clarify what you mean by the high adaptability of the organization. And you need to quantify it so you can measure how adaptable is the organization, how adaptable is it going to be. And then you need to let loose a professional architect who will figure out whether business process re-engineering of some kind is on the agenda at all, and what other things, and can prove that if implemented, these things will actually give that degree of business adaptability. But the point is you can't start off your project before the architect has even entered with the half of the top-level architecture ideas plugged in by the top management in the first statement. That happens all the time. Take another look. Look for the link words, by, in order to, so that. Who put them there? Not the architect, top manager. They've been sold by some company on some great architecture, SOA or something like that from IBM, okay? And they're gonna, we're gonna get great organizational flexibility and system, SOA, okay? That means by IBM or something like that, okay? Anybody from IBM here just got insulted? No? Okay. Okay, so we have to have a very clear, so in other words, the presence of any architecture in the top-level requirements constitutes a major defect. And it's not permitted. It's okay to have some ideas floating around. You just have to put them in a different box called potential architecture. And you will, the architect may even look down that list of what the managers have suggested, realizing that it might be politically smart to sort of agree or politely disagree with the manager. But at the end of the day, the architect has to supply architecture that does supply what the managers actually want, which they haven't even taken a clear position on themselves. In fact, one reason for this specification of architecture is a lot more concrete than very adaptable organization, which is management bullshit. So it's, you know, they've got a concrete idea there. You know, buy that product and everything will happen. Good stuff. Okay. So, now, here's an example of, this is from a banking example I'm going to use throughout. But so here's a high-level architectural specification called a gist. And it's got a tag or name, orbit application base. And we're using language to flesh it out. But the second one is the detail. There has to be enough detail so we know precisely what is expected. So there's a breakdown, which we'll see in a moment, of about 7 different components, D1 being design 1, D2 design 2. And we've taken this high-level idea of the gist and begun to break it down. Now, unfortunately, the moment it's broken down by the domain expert here, everything I've underlined there represents highly ambiguous, unintelligible stuff. Okay? In other words, it can be defined in a very large variety of ways, none of which we know. Okay? And until you define these better, frankly, the architect doesn't know what the architecture is. Got it? So this is that management bullshit. In fact, well, the guy specifying this is a domain expert. He's neither an architect nor a top manager, but he's domain architect in this banking application. So here we've managed the break it down into detail, but this still isn't good enough detail to specify exactly what the design is. So if anybody implemented this, there are a billion different combinations, some of which will take infinite time to install and infinite money and totally fail to deliver the goods from this description. The job of the architect, as in any kind of architecture, is to constrain so that even when fools implement, they cannot fail to implement stuff that works. They should leave it to the craftsman to decide the interpretation of these words. The architect has to retain control of the qualities and costs of the systems by specifying stuff that more or less guarantee those qualities at those costs. And this is going nowhere near that. Okay? So the third one is this idea here called the gist, which is typically what we normally get and nothing more. I've taken Brent, the domain expert, and said, Brent, break it down into a number of subcomponents. So these are his 7 subcomponents. Admittedly, not clear enough, but at least he's broken them down. And I've added one other proviso. He said, what kind of subcomponents are you thinking about, Tom? And I said, I would like subcomponents that can be independently implemented, independent of each other at any time. Why? Because I want to implement some of them early to test that part of the architecture without having to build all of them to get there for 3 years. Why? I want to pick the high-value ones and do them early. I want to pick the high-value to low-cost ones and do them early. So for every one of these, I want you to ask the following question. Could we implement number 5 independently of 1, 2, 3, 4, 6, and 7? Yes? Good. Pass the test. Hope you're right. Okay? So this is decomposition by independently implementable architecture. Gives the possibility of testing and measuring that architecture independently and early and getting high value to cost. Okay? So at least we've done that. But we do need to take each one of these and rewrite them so they're unambiguously intelligible. Otherwise, people implementing them will implement something which is their interpretation, but not necessarily the one we were thinking of that would be great. Okay, they'll implement something bad, cheap, easy, because they can get away with it because there's nothing constraining them here. By the way, in conventional engineering, this is called, in Britain, quantity surveying. If you want to have a clue as to what a building will cost, you'll break it down into the bricks and doors and work to put in the doors and add all that up and you get the cost of the building. You don't just look at a great drawing of a building and say, I think that'll cost about 10 million. You break it down. So this is normal engineering, quantity surveying. Look it up. Okay. Okay, so the fourth rule, dependencies. If you have any known dependencies, write them down. Don't let them stay in somebody's head. So I'm asking our expert here, what dependencies do you know about? We're writing something here, but I have a feeling there are at least 10 interesting dependencies, and I'm going to have to take this document back to our team and say, our domain expert only suggested this one, but XX means I'm Xing out confidential information for clients, by the way, in case you wondered what XX means. And can anybody think of dependencies that our domain expert hasn't thought about? We'll add to the list. So this is an architecture specification. By the way, this is one of 10 major architectural ideas for a bank project that will probably end up costing about 30 million quid. So in very simple terms, this was actually 1 page of requirements, of specification. It done in 1 hour with the domain expert is managing 3 million quid of value. So if you think this looks like too much, ask yourself if using an hour and using a page to specify what you're going to do with 3 million quid is a reasonable act. And would it be more reasonable if you just wrote the gist and left things to chance? And it cost 9 million instead of 3 million. Okay? In other words, I'm suggesting things that I believe have a tremendous return on investment. Spend an hour, save 6 billion or million or something like that. Okay? Obvious. Okay? But we don't do that. We don't have time. We're in a hurry. It's got to be simple. Okay? And yet, we run over budget all the time. We fail on our projects all the time. I wonder why. We never have the time to do it right, but we always have the time to do it over again. Okay, rule number 5. Whenever you have a design, here's D1 again. Again, badly formulated, but what the hell. You are required to write a little, this is a keyed icon from language, and it's this little arrow going to the right. But it translates as impacts. So we're saying this design, D1, impacts the following 2 requirements. These are our top 10 quantified requirements in the bank. They're real ones. Business capability, time to market, and business scalability. Okay? So I'm making, now this is just an arrow. I'm not saying how much, to what degree. That's coming. It impacts it. But I'm just saying this architecture impacts these 2, primarily. Okay? I'm just setting the stage. By the way, if you specify something architecturally and you cannot refer to any of your top 10, then you're wasting your time with that architecture because it's not doing anything vital for you. You know, it's maybe a nice thing, but you've got to assert that it impacts one of your top 10 characteristics to help you move towards your goal. You've got to make that assertion. You can't do that, dump it. Very simple. Okay? But later we'll get to the more trying art of saying how much does it impact it. But this is just preliminary. You've got to at least say there is a connection between the architecture and the quantified top-level critical stakeholder requirements or values. Okay? Now, number 6, the side effects will be documented. In other words, there's a security expert who's got this wonderful idea for a password of about 25 arbitrary characters. And he's not aware, he said, boy, is this secure. Okay? But he's not aware that he's totally destroying necessary user friendliness for the system, so nobody will want to ever use it. It's very secure, but nobody will want to use it. Or every time they try to use it, they're going to, you know, out of 20 digits, you're always going to hit 1 wrong, so you'll never get the password in except by extreme concentration. And this gets silly. Okay? Apple's got the idea. See? You just put your little finger there, wrong finger, and away you go. Okay, that's much simpler. It's got nice user friendliness and as good security as the passwords they say, even though some hackers have had some fun with that too, of course. So now here's a simple table. Here's one strategy, identify binding compliance requirement strategy. This is another different bank project. And the main reason why we did it was to move security administration compliance from 25% to 90%. And we think that this method will give us 100% meaning effect. 100% means we'll get to our goal of 90% compliance on time. Okay, so that's the main. Now it turns out that's fine. That was the main. We have one design which we think will get us there, but it turns out we have these other objectives: security administration, performance, availability, and cost. And unfortunately, every architecture seems to impact almost every critical requirement to some degree. Okay, let's say 9 out of 10. 8 out of 10, something like that. So now this is what engineers call looking for side effects, understanding the big picture. Okay? So in our impact estimation table, I put a 75% for, we'll get 75% of the way from our 24-hour situation with performance, we would need to get down to 4 hours. So getting to 4 hours would be 100%. But we're only going 75, but hey, that's pretty good. We have a side effect, which is very positive for, even though we're mainly designing the binding compliance requirement strategy for the first one. And security administration availability, where we want 24/7 instead of 10 hours or office day, is 0, meaning it has no influence one way or the other, neither positive nor negative. And secure administration cost, we're trying to reduce costs from 100 to 60. We get halfway. That's pretty good. We can actually add up these percentages, since they are percentages and not real scales of measure, and get a magic figure 225, which is the overall impact of that one architectural idea on our 4 critical objectives. So it's a measure of general power, okay, when all things are said and done. And we can use that to compare different architectures, and in a sense, the one with the greatest power should be the winner. Make it very, very simple. We'll take a look at that. But we don't just let people throw in numbers. We ask for evidence. We also ask for both evidence, what are the facts, who's done this before, what are the effects been, can you document it, so that we can do an audit of the architecture. Go back and take a look at that evidence and said, is it true, is it valid, is it relevant to us, do we buy into it? Okay, you can't just if you let people spout numbers, they'll do that. That if you let them spout numbers and make them responsible for evidence, which they know can be checked, they'll take a slightly more responsible position. Okay, evidence and source. And then there's this little matter of how much it's going to cost to do. If several had 225% overall impact, but one of them was dirt cheap, you'd have a greater efficiency of the architectural idea, meaning value for money, value over cost. And in general, picking value to cost is smarter than just picking value without regard to cost, because you have limited budgets. Okay? An architect should be doing that. We also have a concept called credibility, where if somebody's just spouting a number, they say, how did I get that number, and they do that, just guessing in the wind, they get 0.0 credibility on my scale of credibility. If, however, they said, oh, our corporation has measured this 500 times in a row, and it always gives exactly these results, well, that's pretty close to credibility 1.0, or 100% credibility. Okay? So the evidence and the sources are, we look at them, and then there's a table, and we then say how strong or how credible is this estimate. And then this number here is the value for money. It's this 225 over the 15 man days, something like that, which is probably in a percentage or something. Anyway, but that represents value for money. That's just value without regard to money. Okay? Beginning to see a picture of what I mean by quantifying how good your architecture is with respect to the objectives. Okay. Now, the rule number 6 says that, this is also rule 6, looking at side effects. There's another way of looking at it, and that is to bring out all the dodgy stuff, which I classify as assumptions, dependencies, risks, impacts, and issues. And, risks and issues. And so here is the real summary in the scope of our 1 hour on the 1 page with Brent. These are the things I said, tell me all the assumptions you can think about. And he did. And he ran out of steam after a while, but his colleagues can no doubt put in several assumptions. You can build a little database of background knowledge of this design. And you should. You shouldn't just rely on one person, even though he's the expert. The other guys have got quite a bit more. And then dependencies, he only had 1. Risks, things that could go wrong. He had about 5 of them. I'm sure his colleagues have more. And issues are questions we've asked, but we don't have an answer. But the answer could be a risk, a dependency, an assumption, or, in other words, dodgy stuff we don't know until the question's answered. But the point is we capture everything, and somebody has to deal with it systematically. So a manager could say, time to go deal with all this stuff, get the issues answered, and find and design architect to mitigate against these risks. I want to see the mitigation for every bloody risk here, part of the architectural process. So this builds that up. Number 7 is, in a sense, what I just went through. It says that for every estimate, we have evidence, credibility, sources. There's below every number on the table is about 6 or 7 levels of information, if you care to take the time to put them in there rather than just a wild numeric guess, justifying the existence of that number and giving it credibility. Rule 8 says that finally, you should put this all together in what we call an impact estimation table. So here's a real one for a real bank doing compliance analysis. And it's the one we've been talking about. I'm trying to think, is there any way of getting better focus on the projector from the back? But I don't know. I think we have to live with what we got. But the main point is, on the left-hand side, we have the 4 critical objectives. We have across the top, we have some strategies that have been proposed. The person planning this, John, has done his best to estimate roughly what the relationship is. It gives him confidence that I think I have a lot of pretty good ideas, and I think I can prioritize which ones we ought to start trying out. Here are the different levels of credibility, 0.9, 6, 6, 7, 5, 9. And here's the cost-adjusted percentage impact, in other words, value for money ideas. So for example, this one has 262, and this one has 90. In other words, this one has about 3 or 4 times the value for money that does. So in terms of deciding which one should I do in my agile strategy in the coming month, the answer is the one with the best value for money. Now, it might not really have the best value for money, but we'll soon find out, won't we? Okay? And if it does, we keep it. If it doesn't, we dump it, and we go to the next. So what you're doing initially here is you're making estimates with a view to generating a hypothesis, as in scientific hypothesis, of how good the architecture is and what value for money it is. Then you use that information from this table to decide what to do first and try out first early in your project. You implement it, you integrate it, maybe into an old system, just to see what happens. And then good architecture will survive, bad architecture will die. And this is the dynamic design to cost architecture, which I'll talk about a little bit later. Okay. Now, I told you everything was on a page. So this is the one page done in 1 hour to manage 3 million quid of IT system in the city. And this is just the start. This is the 1 hour. Now, we can give it to the team, which is 9 or 10 other people, and say, anybody got any additional ideas or see some false ideas, please tell us. You're building up a database about each architectural component, which enables you to prioritize, enables you to analyze risks, and enables you to argue causes, and even do auditing. Is the architecture sound? Are these assertions of the numbers based on good evidence or not? All this kind of stuff is enabled through this. And it may seem like a shocking lot for people who are used to just saying modularization, okay? But it's only one page, it's only 1 hour, and it is managing 3 million quid of spent. So think about that. I don't think that's too much, but you might get shocked at this. Okay. Here's just the left half, which we've looked at with the detailed descriptions. Here's the right half with all this management of risk and dodginess, and that's enough. Let's see, I'm going to do several things. Take a look at my watch. Good. And take a drink of water. And maybe give you a moment to reflect. That was good. This is my world. Every system has some core functionality. Not very sexy, not very interesting, just the business you're in. There's far too much focus on functionality in software engineering, but that's because the programmers need to know what the functionality is to program it. And it is vital to the system, but the business already has that functionality, or they wouldn't be in business. So you're just replicating what already is there, but you're replicating with a view to giving it better qualities and costs. Okay? So, and then on the right-hand side, these arrows represent variable dimensions of performance and quality. The little arrows in the middle represent maybe an objective to get to those levels. Okay, so the architectural problem becomes get to those levels within those budgets or resource constraints. This is the multidimensional world. Just try to write it as a language, drawn icons picture. So, what is architecture? Well, I've sweated, and as I told you, at least 200 people have different opinions, some of which I halfway agree with. And my definition is there. I'm not even going to read it, and I've had to write a whole paper explaining it, getting into detail. It's something beyond the scope of this. But anyway, that's my opinion for the moment. And this is what I'm trying to do with the definition. Again, not here, not now. But if you say, what the hell is Gilb talking about here? I have tried to justify this. There's a whole paper on the subject at least the website. There it is. There's a website of the paper going into detail about it. So anyway, I had a shot at it. But I'm under no illusions. I'm the only one in the world who seems to believe exactly this, and everybody else, including all of you, have a different opinion. And we all have a right to our opinion. But if you study mine, you might get some insights into something, and hopefully that's positive. Let's skip that. Here's another model of what's going on. If we take evolutionary step 1, or cycle 1, or sprint 1, whatever you want to call it, that first cycle of delivery, here we have our basic model of what we want to do. We need those functions, we need some reliability, usability, we have some resources. Step 1 may plug in some functionality, so actually we've got step 1 and step 2 simultaneously here, fine. And then step 1 and 2 will consume some resources, that's the blue stuff there, but step 1 and 2 will deliver through its designs some progress towards the goal. Those are the red arrows, okay? This is just a way of trying to visualize what is architecture all about, what is design all about, okay? And you continue until either you reach your goal levels, the ones that are deemed satisfactory or contracted for, and or until you run out of resources, like there's no more time, there's no more money, so I cannot progress it until I get more time or money, okay? But so definition of done, which agile people have fun trying to figure out, is that you've reached the goals, and hopefully within the deadline and the budget, which is perfectly possible if you use this particular means of doing things. We'll let that example be. Here's my world again. Here's a simplified version of what we just looked at. For every quality and performance characteristic, there is a scale of measure, symbolized by the arrow. On that scale is a baseline, like our old system or a competitor's system we have to compete with. And then we call that the zero idea, the base, and, or the benchmark. And then there's a target, which we typically call the goal. And targets where what we're trying to get to in the future. So the differential between the baseline and the target is the degree of improvement. And all projects are about improving characteristics like this. They're not about functionality. That's just the minimum to be in the business. It's uninteresting. But the reason the book is called Competitive Engineering is because we're trying to deal with competition, be better than the next guy. And that's not about functionality, because everybody in the same business has the same functionality. Banks charge interest. That's not a competitive thing. It's just you're not even a bank if you don't do that. Okay. So, what if you could reduce your costs and offer lower interest rates? That would be competitive. Okay. So banks are trying to, in theory, lower their costs. Practice, maybe something else. And, but the interesting thing is, whenever you see these words like enhanced, improved, better, how are we going to make that clear? And the answer is, a scale of measure with 2 points gives an exact, precise, unambiguous, and clear definition. Isn't it a simple idea? All those words, enhanced, improved, impressive, you need to clarify that numerically. It's the only way to do it. Words don't help, okay? With 2 points, 2 numeric points on a well-defined scale of measure. Okay, so you should go through all that bullshit with all that enhanced, improved stuff and say, what is the scale of measure? Where are we starting from? What's our benchmark? Where are we trying to get to? Now I know the gap between what we have and what we need to architect. That's my architectural challenge. I'll have a set of maybe 10 such gaps. That's my primary input to architecture. I have to find architecture that bridges the gap. For real, really gets me to the number. And I can evaluate, theoretically and hypothetically, any architecture by saying, okay, I've got an architectural idea. How far along am I going to get? And let's just say I'll get about 45% of the way. Okay, so say so. That's all that architecture is good, but not good enough. We need either to replace it with a more powerful architecture or supplement it with other architectures that move on towards the goal. Okay? We now have described, in a nutshell, the architectural iterative process. Okay? You're challenged by stuff that moves you forward. Okay? You evaluate how far forward your ideas get you. When they don't move you all the way to your goal, you must either replace or supplement until you have a hypothesis of how to get to the goal. Then you have a theoretically complete set of architecture, which you can now try in pilots and other ways and verify the hypothesis or not, that your architecture really gets you to your stakeholder goal. I've now described architecture engineering in a nutshell. Isn't it simple? I mean, anybody say this is intellectually beyond me? I'm one of these Scrum people who need exactly 3 things and I can't think of a 4th one. It's too complex. You know? I mean, we have a lot of dumbed down culture because people think you're stupid. I think you've got terribly difficult projects, and I know you're very intelligent, and I think you can cope with this. But you sort of have to want to cope with it, because right now, people are not here in this room. They're not going to push you into it. You have to grab it and say, this is the right way to do it. I will be a superior architect. I'll blow people's minds with my capability of delivering architecture. And at some point, some manager will wake up and say, gee, all our other architects ought to be trained to do this. And would you be the chief architect, by the way, since you obviously know how to do this? You can enhance your career seriously here by knowing how to do it. But be careful. You know, it's dangerous stuff because it's new to the culture. You know, you could get burned at the stake for less. Just do it. Let the results speak for themselves. And people may say, how the hell did you get such good results? Well, I don't know if I even dare tell you, but I will train your other people to do it. Okay? Here's just another simple graphical model of design A and design B consuming multiple costs and delivering some set of objectives. Just a graphical way of understanding what's going on. So here's an example of using these ideas at the level of corporate architecture. So this company is in London, and the time we were working with them had about 800 people in London and 200 in Sweden, and it's a software house. They're generating software for the telecoms industry. Okay? And they knew that they were a bit long in the tooth. That is, they had about 8 years of developing, let's call it spaghetti code. So they had a serious technical debt problem, but nobody, as usual, done anything about it. But they realized that times were changing, iPhones were coming in, serious competitors, this kind of stuff, and they had to be nimble and change their software massively, but it wasn't easy. So they knew that they had to change their organization radically and their software architecture radically in order to deal with the technical debt. And they also had figured out a number of things to do. Across there, we'll get back to that. But they'd costed some of them, like 2.85 million quid. And all the things they dreamt about doing, they said, we need 50 million quid over a several-year period to change our organization. We're now working at the CEO level directly. Peter. Oh, sorry, that was David. Right. And now the problem was, small problem, they didn't have 50 million quid. But their corporate owners had 50 million quid. So Mr. Moneybags was coming to London. We could write a check for 50 million quid. And the CEO was quite enamored by this way of thinking, as CEOs tend to be, you know, clear thinking at the top about top-level things. And so he said, Tom, would you teach my chief planner, Mr. Behrens, to do your method? So I used 1 hour, and I taught him to the whole method. And most people need a week. Like, you're very smart people, but you need a week to understand my methods. By the way, free courses at BCS for a week on these methods, 31st of March to 4th of April, okay, in case you're interested. Now, the free courses for BCS members, others must pay 30 quid for the whole course for coffee. Pays off to join BCS, it turns out. Now, Mr. Behrens overnight, because the Mr. Moneybags are coming the next day, wrote down what they call their business objectives. So these are what we call tags, or names of objectives. He then wrote down some kind of a scale of measure as best he could, pretty good for an amateur. He then wrote down the goal for a future year, 2000 and X, of exactly what they intended to do. So this is top 10 critical objectives for the software organization quantified. They have a culture in this organization, a thing called stretch goals. That is, this is the main thing, but if you have enough resources to get there, we value as stakeholders getting to this level. Beyond that, we have no value. Don't worry about it. Okay? That's not bad, overnight, capturing the goals. Okay? Never been done before. And typically in most organizations, by the way, anybody here say, Tom, I could show you, if it weren't confidential, our top 10 objectives quantified somewhat like this. How many people in this room would, you already started working on it after you went on the seminar with me, right? Interesting. So this is what we found. People don't have the top 10 quantified. You can teach it in an hour, smart fellow. You can do it overnight. I believe that all projects should start with the top 10. We took one major bank in London with 5,000 IT employees and 4 billion quid in budget annually. And we surveyed, by sampling, 500 projects and concluded at the technical director level that no projects had clear objectives like this at all. And the technical director said to me, Tom, it's such good common sense that we should have clear. We're spending 30 million quid on some of these projects. It's very good common sense. We should have them. And it's so simple. Why don't we do it? And to make a long story short, aside from saying no universities train your smart graduates in doing it, no, you don't have a culture that teaches them this is how we do it. I said, his first name, we'll call him John for the moment, it's not his real name. I said, John, you regularly, for the last 14 years, have handed out 30 billion quid for projects that have no clear objectives. That's why you don't have any clear objectives. Try saying, I've got the 30 million quid here if you just spend an hour writing a page with clear objectives for me, so that I know what I can hold you responsible for my 30 million quid. That would get some action. But nobody's even, there's a management so dumb, they're not even asking for clear ideas before they fund projects. They're not stupid. He's not unintelligent. He's just a victim of a culture of the business schools that don't teach this stuff. They teach accounting. They don't teach quality accounting and stakeholder value accounting. That's why they went to balanced scorecard, to get away from all that financial stuff over to the other stuff, the values. Okay, but that wasn't done very well, but it was an attempt to recognize that there's something called too much bean counting and too little value counting. Anyway, so this was set up, and then the same Mr. Behrens, which is his real name actually, Christopher Behrens, he's a Dutchman. How many Dutch do we have in the room? Good people, the Dutch. Okay. I've just been invited to the architecture conference in Holland next year, so do come and join me. I said yes, 25th of November or something like that. He then took and he did impact estimation for all of the strategies they'd been thinking about. The only really clear numbers he has, the 2.85 million, 0.45 million, 3.21 million pounds. They'd costed these things, but they didn't have the money. But now you'll notice he's making estimates in round numbers, 10, 15. We don't have data that permits anything else. We consider ourselves lucky to get order of magnitude. But to know the difference between a 5% impact and a 50% impact is good. That's order of magnitude understanding. Okay? So the first instance is just the best we can. Wherever he had the time and energy during the night before Mr. Moneybags arrived to write down his evidence, he has a little note in the spreadsheet where he has the evidence. The rest of it, he says, I'll defend it orally. I remember, but I don't have time to put it in there. In theory, if you're doing this properly, you have more time and you have evidence all the way, right? In practice, overnight, when Mr. Moneybags is coming at 9 o'clock, you do the best you can. So you write down evidence for some of it and not others. Okay, so this number represents sort of an averaged sum of all of these. In other words, the power of the different objectives. This represents the cost, and this number at the bottom is, as usual, the value for money. Here's 358 compared to 106. So this is 3.5 times more value for money than this. I would start implementing telephony, whatever the hell the definition of that is, which is somewhere else. That's where I'd start, because it just has more value for money. In other words, in shorter time, you will get more value. That seems the sense. It would be stupid to do the highest cost things with the least value first, wouldn't it? and yet that's what you're doing. You know why you're doing it? Because you're not evaluating the value, you're not evaluating the cost, you don't know. So you're doing something else like it's easy to build, or it's fun new technology. But you're not choosing consciously the value for money because you don't even estimate this. You don't even have the top 10 objectives quantified so that you could begin to think about it. You don't have you haven't spent your hour building the page of the top 10. Actually, I use a day to do that normally. Okay, now, serious look at the old watch here, because you're all thinking coffee, restroom, about 16 more minutes, and I'll shut up. Okay. We have a process for starting up any project. We're using it, for example, at large banks here in London, called a startup process. Now, I know you can't read that, but I'm telling you, you will find it on my website. It's how for about several decades, have started up any process. It's like a feasibility study time-boxed to 1 week, no matter how big the system is. We've done this on 25 airplane projects at Boeing. Forget software. Okay, that was as early as 1989, 90. But anyway, the standard for it is written here. But what I'm going to do, I'm going to run through a quick case study of showing how we do it. And then you say, oh, that was cute. I wonder what the detailed rules are. Well, they're here. Okay, again, these are one-page snippets of what to do each day of the process, a short and sweet standard. Those are day 3, day 4, and day 5, boss approves, delivering the architecture next week to measure and see how well it works. Pretty dramatic. Okay, so here, first Gulf War, Stormin Norman, Bush, and Stormin Norman came back victorious general from the war, and he said, you know what? We have a crap IT system called Persinscomp, the Army personnel system. I know you spent 8 years developing it, but it's so bad that if we were dependent on it, we would have lost the war. That got people's attention. Okay. So and I got assigned to the task, help these people save themselves from themselves, because they'd spent 8 years building a crap system. Nothing new. That's the usual for most IT systems, right? So I'm spending a week with the team there who's been managing the system. And they say, what's the agenda, Tom? And I said, Monday, we're going to quantify your top 10 objectives. Okay. Tuesday, we're going to do the architecture. I just want 10 ideas, maybe a sentence each, on a page. That's all, the whole output from you 10 people for all of Tuesday. Okay, and I did it. Wednesday, we're going to do an impact estimation table and see how well the strategies seem to fit. I mean, if they don't fit at all, you're nowhere near, you need more strategies, more time on it. If they sort of fit, time to start validating them. Don't worry if they completely fit. You don't have to worry about that. Thursday, we're going to, from the architecture, select a sub-component of it so that we can try to deliver some stakeholder value for real next week. And at this point, they stopped me and said, you're crazy. It's impossible. The Pentagon's such a big bureaucracy. Nothing's going to happen next week. And all that, totally impossible idea, but of course, it was possible or I wouldn't be telling this story, right? And on Friday, General Pellicci comes back from playing golf all week and is going to either say yes or no to these plans. Okay? So see what happened. Here on the left-hand side are the top 10 goals with the name of them and the past number, the benchmark, and the degree of improvement number, the goal. Okay? The scale and everything looks like this. We've got a whole set of this stuff. On Tuesday, they had their high-level strategies, and I rather suspect they had been looking at these but not been funded or empowered to use them. And now they had a terribly good excuse. The power of the general's anger was behind them supporting them. They were quite happy for that. And so they brainstormed. This is, if you like, the top row is the output of Tuesday. That's just brainstorming some good architectural ideas. And typically a whole page, where this is just the top of a page of technology investment, is done like I showed you. And then finally, we get to Wednesday with the impact estimation table, which looks like this. Okay. There's one thing on this table which we haven't shown up on others. We add the numbers for all the technology across, and we get sum. And now, in theory, if they added up, which they don't, if they did not collide with one another or have synergistic effects, then if you got to 100, you'd have just enough architecture to get to the goal. And the fact is, we don't know enough to actually consider the thrashing effects, the synergistic effects, and God knows what. So we just add up the numbers. But now, if you added up the numbers and you got 35%, I'd say we haven't done enough architecture, clearly, even by our own estimates. If you add up to 100, I'd say, in your dreams, you've done enough architecture, but in the real world, you have not. You need what engineers call a safety factor. And since we've been doing this for decades, we know what kind of safety factor management was. Factor 2, at least. So when the numbers add up to about 200%, which you notice they coincidentally do, it's somebody saying we need to beef it up and have more than enough ideas. So when some of the architecture fails, we still have enough ideas in back of us to go forward. Okay? If you had no further ideas beyond 35%, there's a sign that if there are no such technologies, you would never get to your goal. It's time to talk about reducing the goal. Okay? But if you're at 200%, say, well, that's fine. So that gives us confidence that even if some fail, we have some backup ideas. Let's start moving. We needn't quibble. We needn't do more architecture. Okay? So that's what that's doing there. Now let's analyze this a little bit. Here's the performance to cost ratio. Here's a pretty good one. It's 16 to 1. Here's the total impact on everything. Here's the total cost idea derived from 2, 16 to 1. But this fellow over here is twice as powerful, 29.5 to 1. So business process reengineering is rated by them as being far more value for money than anything, far and away. So what would you like to start with in the coming quarter of a year? Testing architecture. Try business process reengineering is a good case for, right? Well, wait a minute. I like to do weekly increments of delivering value, right? So, this business process reengineering thing is going to take a long time. Isn't there something I can do in a shorter time that has very high value? So we let the spreadsheet logic scan this, and it finds the 200% up there. And it said, that looks like a very powerful thing. I wonder how much time that will take. And somebody says, about a month. Ah, now we're getting there. Okay? Is there any subset of this that would business process reengineering for availability, which might be able to be done in a week to get me a feeling? Yes. Good. That's what we're going to do next week. You're now looking at a tool for decomposition by implementable value called an impact estimation table. And one customer who's actually in the slides, but I'm wondering about the time, they automatically flag things. They have a red, yellow, green indicators. And red means very high priority, you aren't anywhere near your goals. Yellow means you've reached a tolerable minimum level, but not your goal. And green means you've reached your goal with the design. And it tells you both in the design phase and in the operational delivery phase what you should prioritize. Okay, so in other words, the logic is so impeccably clear, crystal clear with numbers that spreadsheets can tell the architect and the project manager what they should do next week automatically. That's clarity. I've always strived, being an old programmer, I've always strived for clarity enough that a computer can duplicate my processes. So this is not an accident, this is my life's work. I've invented the thing called the impact estimation table. Okay? Right, so that's a real one. Now, having reached the point where I should probably drop the rest of the talk except the principles at the end, I might just do that. Yeah, 8 minutes left. I'm going to, yeah, I can't resist this. I mean, this is what the general thought of the effort. Great planning method, better than anything we ever learned at West Point. Comment. Okay. Save the nation. But, on. Yeah, so here, yeah, actually I don't have to skip so very much, do I? We're there. Maybe I could tell the end of the story. On the Thursday, when Thursday rolled around, they came and said to me, Tom, we have found what we can deliver next week. And I said, good, that was the idea. Yeah, but you remember we said that was totally impossible and unthinkable at the Pentagon. Yes, I remember. What did you do? They said, you'll never believe we never thought of this in the past 8 years. I said, I believe you never thought of it. What the hell is it? I'm getting impatient. And they said, we discovered that the reason the general got 3 hours from inquiry to answer when he had 10 hours before he started the 3-day war was that when he logged in, he was put at the end of the queue of 15,000 soldiers using the planning system to ramp up the war. Yeah, so the solution is very simple. We add some code, if commanding general, move to head of queue. I said, can you do that by next week, very skeptically? And they said, yes. I said, how do you know? Very skeptically. They said, because we've already done it. During the planning week, they cracked one of the 10. And then the generalization of that is, rank has its privileges, and higher ranks go to head of queue. Captains go before corporals, and et cetera. Otherwise, you can't run the military any other way, I think. Okay, so there's the General Schwarzkopf at the head of a queue, where he properly belongs, in case you wondered. Yeah, okay. So, winding down my talk with the time, these are the 10 principles. So the first one is that architecture is a hypothesis that needs to be proven by implementation and measurement. How many people, let's try again. How many people actually measure how good their architecture is? Good. I'm registering about 5 hands for the video camera out of, I don't know, what are we, 200-300 people or something like that? Not much. Okay. Architecture components will contribute to a variety of attributes. One design may hit many qualities in interesting ways. And it'd be silly not to take these gratuitous side effects, which are freebies, and say, and even say any architecture which hits many attributes pretty well beats any architecture that just hits one attribute even better, but none of the others. Okay, balanced evaluation. The third one, the exact attributes the architecture will display is a matter of the exact design engineering, which may be after the architectural phase, and the exact implementation in the exact system that happens to be there at the time, later combined with additional things that are piled on top of it which may destroy it. In other words, pretty tricky business and not simple. The architect does not have total control, but they can exercise a great deal of control. Number 4, the architect is responsible for all the attributes of the architecture they suggest, all qualities, performance, cost, and constraints. And responsible means you have to document what you know, document what you don't know, low credibility stuff, be honest and open, transparent about it. And you don't do that yet. Okay? The architect is responsible for understanding and mitigating all risks of deviation from good levels of attributes. So you must understand the risks, understand the spread of results from the architecture in the field, and understand that you could be at the low end of it if you're unlucky and things like that. Number 6, the architect is responsible for all attributes at a defined level. In other words, if the level is the corporate level, then you're responsible for delivering value to the corporation. Okay? I think we have too much of a mentality, we're down at the IT level, and we sort of want to get good code without too many bugs in it, which is what the Agile Manifesto says is primary. Okay? And they don't talk about delivering value to stakeholders at all. So fail Agile as a culture, at least expressed in the manifesto. Here's an Agile method, which is at the architectural level, and it's the value to stakeholders level. It's called EVO. Okay? The architect is responsible for defining the architecture in somewhat more detail with all those issues and risks and decompositions and God knows what. And in order to give a reasonable level of control over the result, that's always been an architectural responsibility, get control. Don't blame others for bad results. There are limits to how far you can go, but you can go a lot further than you're going today. The architect is responsible for dealing with the unknowns and uncertainties in a very cognizant, upfront, clear, documented way. And finally, in fact, for mitigating the issues by further design, or at least having backup designs if things go wrong. Okay? And number 9, I feel like David Letterman here. It's a strange reason. The architect, like other engineers, is responsible for preferring, like any good engineer, conservative architecture, meaning we know how it works. New stuff that nobody's tried, they'll try and sell it to you. Of course they will. But do you want to take the risk of your architecture failing? Okay, so general characteristic, scientists dealing with the unknown, fun, new stuff, right? But engineers, conservative, using known technologies with known attributes is the dominant heuristic of an engineer and should be the dominant characteristic of an architect working for a responsible organization. If you're at a university and you're doing research, you can have fun and games other ways. Okay? And finally, number 10. You have to measure what goes on in real life and get credible, reasonable measures of how things are working, and if they're not working, you need to dump them very fast, fail fast. The exhortation is fail fast. I'm telling you exactly how to fail faster. There's a difference. Okay? And finally, if you wish to go into more depth and you want to at least do some self-study, there's the book. You want a free course at British Computer Society, join the British Computer Society Specialist Group on Quality, sponsors my courses. We do about 5 or 6 a year. They're absolutely free. We take 40 to 60 people at a time. And we also do an architecture engineering course in Norway in English, which will be the first week of January. If somebody wants, even from Britain, to come and join us, a little trip to Norway, do come and join us. So free book, free courses. Can I tempt you into growing up a little bit as architects? Thank you.